When following any tutorial, check the lesson in the Visual Components Academy, and if the Download Files option appears, you can download the example files.
Hello, JP here, and welcome to this tutorial to learn about Assembly Operations tool. Assembly Operations tool makes building assemblies with robots much easier and faster than before. Let's first take a look at what we have in this example layout. Here we have a conveyor which brings these individual parts that we are assembling to this track-mounted manipulator robot. Here on the other side we have a workpiece positioner and a welding robot, which is also mounted on track. And here we have one simple but very important thing, the recrap station, which is basically a table with an angled surface and two edges that stop the parts. And last but not least, here we have the completed assembly that we have imported from a CAD file. Okay, let's then go through some preparation steps that will help the actual assembly operations process. First, we want to position the assembly to the workpiece positioner. So we select the assembly and use the Align tool. And from the settings we select Set Position and let's use Center for the snap type. Now when we select the center point of the assembly bottom and the center point of the workpiece positioner's table, we get the assembly nicely aligned to the center. Now we'll just have to move the assembly a little bit up and select the Align tool, and from the settings let's use Set Projected Position and Snap Type Edge at Face, and we'll select the assembly bottom and this face here. And it seems to be correctly positioned. Now we can use the Attach to attach the assembly to the magnet on the workpiece positioner's table. Okay, next we will create a new subprogram. Let's call this as an assembly helper. The idea here is that we use the Assembly Status Designer tool to define the assembly order. So we go to the extras and click Assembly Status Design. Then we select the component, so in our case it's our assembly here. Then we click Disassemble, and after that we start selecting the parts of the assembly in the order that we would disassemble this assembly. So it is actually the reversed assembly order. And now that we've gone through all the parts, click Disassemble and Create. And here we have the assembly statuses for different states of the assembly. Then we could create two more subprograms. Let's call this first one as a grab part. Later, when we are grabbing a part, we will call this program. In real situation, it would have the necessary inputs and outputs to activate the magnet grappler, but for simplicity, we just use a small delay here. Then the next one is called release part, and it is just the same, but we will call this when the part is released. Okay, now that we have all the preparations done, we can start to program the actual assembly process. We have our main program still empty, and to keep it in good order, we create own subprograms for each assembly step. So each individual part will get its own subprogram. We start with creating the subprogram for the first part. Let's name this as a part A. So we want to pick this bottom plate from the pallet, place it on the recrap station, pick it from there and place it to the workpiece positioner. To do that, we first select the robot and then select the Assembly Operations tool, either from the hover panel or from the statements toolbar here. Next, we just pick a grab position and the Assembly Operations tool creates the robot movements needed for the grab. The grab panel also appears, and from here we can scroll through the movements to see that everything is in order. Then let's take a look at the process tab. Here we can add extra statements to any step of the grab process. Remember the subprogram grab part that we created earlier. We want to call that when the robot reaches to the grab point. So we select the grab point, click on the green plus icon here, and select Call. Now we can select the correct subprogram from the drop-down list here. But we don't want to do this manually each and every time we pick a component from this palette. So what we can do is to go to the Database tab and create a template for this. We just have to give the template a name. Let's call this template as a pick from palette and click the Save button from here. Later, when we are picking another parts from here, we can just apply this template. Notice that when we added the call for grab part to the Process tab, it can now be seen also here on our program. Okay, now the grab statement is done and we want to create a release statement. To do that, we click Create Release Statement. From this panel, we have to choose, are we adding the part to an assembly or are we releasing it to some other location? Since we want to place the part to the regrab station, we click Release. Next, we click Align to regrab station and Align to regrab station panel opens. Since we don't yet have any regrab stations visible here at the drop-down list, we must first add one, clicking this green plus icon here. Now we have to select the bottom and two sides of the table. And after that, we have the regrab station available on the drop-down list here. Let's select that. Next, we have to add alignment points to our part. So we click Add Alignment Points and then we select the part bottom and at least two sides of it. After that's done, we click the Add Alignment Points button again, and now we can select the configuration here on the list. Let's check how the part looks on the table. It looks quite good, but if I wouldn't be happy with the orientation of it, I can add more alignment points to get more configurations available to choose from. So I click Add Alignment Points and select two more sides. Click the Add Alignment Points button again, and now we have 4 different configurations where to choose from. Okay, that's good. Now we can close the Aligned Regrab Station panel and click Save Current Positions. And finally, click Create Release Statement. And tada! Here are the movements needed for the release. Now we just want to add our release part subprogram to the Process tab in a similar way that we did with the grab. Let's next take a closer look on the point of the program where the part is released on the table. The idea is that the robot drops the part on the table and gravity takes care of aligning the part with the sides of the table. So we want to apply a small offset here in every direction. We can just click on the field and modify values by scrolling the mouse wheel. Okay, otherwise everything looks good here, but it seems that the robot is just barely reaching the position, so we could move it on its track a little bit. And now that everything is set up, we go to the Database tab and save these settings to a template, so that we can use this again when releasing other parts to the regrab station. Let's give this template a name and click the Save button here. Then we want to grab the part from the table and move it to the workpiece position, to the location that we defined in the preparation phase. So the grabbing part of this process is pretty similar than the previous grab. We select the Assembly Operations tool, pick a grab position on the part, and after that we can quickly review the motions. Then we add the call for the grab part to the Process tab and save these settings to a new template. After that, we can proceed to create a release statement. So we click the Create Release Statement button. And now we want to add this part to an assembly. So we click Assembly. Now we must define to which assembly this part is added. And this is where our Assembly Helper subprogram comes in handy. We can go to our Assembly Helper subprogram and select, for example, the first assembly status here, so that we get the whole assembly visible. Now we can easily select the assembly by first clicking the Select from 3D World icon here, and then selecting our assembly. Next, we'll have to define which feature this part is in our assembly. The items in this list are sorted so that the features with most similar name are on the top, so probably the first one is the right choice. But with our whole assembly here visible, we can be sure that we select the correct feature, because the selected feature here is highlighted in the 3D world. Now that we are sure we have selected the correct feature, we can hide our assembly. Go back to the Create Release Statement panel and click Create. And wow, there's our release statement. Now we can fine-tune it a bit. Let's move the robot a bit forward on the track. Go to the Process tab and add the call for release part, so that the magnet releases the part, and then go to the Database tab to save the settings to a new template. And there it is. We completed our assembly process for the first part of the assembly. Let's now check how it works. Since we used subprogram part A for it, we have to first add a call for it in our main program. So let's select our main program, add a call statement here, and select the part A subprogram from the drop-down list. And now, let's play the simulation. Beautiful. So, this is how the assembly operations tool is used. Now we have gone through all the steps, and the assembly of the next part would be just repeating these steps again and applying the templates that we've created for each different grab or release position. Hope you enjoyed the tutorial. Try it on your side. I will also leave this example layout next to the tutorial on our Academy. Thanks for watching and have a great day.